All right, Algebra 1. Let's go. All right, we are in section 4 today. We are going to be working with radicals, that is square roots, okay? But we're going to be simplifying square roots. So that means that they won't always work out perfectly, all right? What I mean by perfect square root is like, what's the square root of 25? It's 5. What's the square root of 36? It's 6. Those work out perfectly. But what if you have something like the square root of 24? That doesn't work out perfectly. But we will learn how to simplify the expression and not just get a decimal answer. All of these problems you could do without a calculator because we don't get to use calculators. So we are learning how to simplify them and not just plug something into a calculator and get a decimal. That's not what we're doing here. Okay, this is important because you will be doing this again in this chapter, and you will also be exposed to it again later on in other math classes, geometry and algebra 2. Okay, let's get into it. All right, so let's go ahead and zoom in on the stuff that we have to copy down. And you know what, before we get into it, I just want to pump you guys up. All right, I've been noticing you're working harder, you're putting forth the effort. Keep doing that. All right, some of you guys, you started out strong and you're still doing it. I just want to say, keep doing that. All right, some of you guys, I know math isn't your thing. That's fine. It really is fine. I know I'm the odd guy. I like math, but if you don't like it, you still put forth that effort and you will see a good outcome. All right, you just got to keep doing it every section, every section. All right, so here we go. Like I said in earlier videos, guys, example problems are so key here. In other words, really important, all right? So all the words, all the basics, like you get the words here, you get the algebra stuff here. I don't think that's going to be helping you as much. That might, in fact, confuse you a little bit more. Let's jump right to copying down the example problems. So you could see, let's say you have the square root of 4x. That can be broken up into two individual parts, square root of 4, square root of x. Okay, we don't know what x is. X is anything. We have no clue what x is. So the square root of x is just the square root of x. We don't know it. But we do know that the square root of 4 is 2. So that's what I mean by we're simplifying square root expressions or radical expressions. All right, this symbol, that's called a radical. So there's a radical right there. So take the expression, break it down into individual parts, and then simplify the part that you can right there. But right here, we can't simplify that. So just leave it. All right, so there we go. Let's move into the second one right here. Now let's take a look. What if you're given one entire fraction all under one big square root sign? That's what we're given here. One fraction under a full square root sign. You can do the same thing that we did in the last problem where we had multiplication, broke it down into its parts. Same thing can be done. Now we have division and break it down into its individual parts. Instead of saying 16 over 25, what's the square root of that? Break it down into what's the square root of 16 divided by what's the square root of 25, and that simplifies very well. Square root of 16 is 4. Square root of 25 is 5. Okay, so that's helping us to break things down into its parts, and the individual parts, then they could be broken down rather than looking at the whole problem as one big piece. Okay? All right, let's get into our notes right here. So again, what I highlight, I find to be very important. I believe it's all important, but what I highlight, I know is very important. Okay, key things, you got to remember your perfect roots. Okay, and what I mean by perfect roots, specifically from 1 to 20, is like, what is 1 times 1? What is 2 times 2, 3 times 3, 4 times 4, 5 times 5, all the way up to 20? 10 times 10, 15 times 15, all the way up to 20 times 20. If you can remember all of those and have it perfectly memorized, that will serve you very well in this section and probably for the rest of this chapter. All right, it's going to help a lot. Okay, another thing very important for this section, factor trees. All right, we used to do that all the way back in elementary school. You do a little bit of it maybe at the beginning of algebra, but then we kind of let it disappear. Factor trees, we're going to be doing a lot of that in this section, so you're going to see it because that's super important in our simplifying the radical process. And then the last note here, can't. That is a big no-no. You cannot leave a radical in the denominator of a fraction. You're going to see example problems that I will do where we don't leave a radical in the denominator. The only times that it seems to work is if that radical simplifies perfectly. In other words, it is a perfect radical. And you'll see one of those in my example problems too. Okay, the key piece you'll have to do is multiply the entire fraction by that denominator. But again, follow my examples. Let's do some. Here we go. Okay, square root of 24. 24, it's not going to be a perfect root. All right, it's not like square root of 25. That's not possible. So factor tree, that's what we're going to use. So we break this down, and I want you to make sure you notice both of these factor tree pieces, we have square roots because I'm breaking down the square root of 24. That's the same thing as saying, let's use 12 and 2, something real basic, okay? You could use other numbers and you will still get to the same answer. Now, what you should notice here is the square root of 2 can't go anywhere, all right? 2 is a prime number, so I circled it because we're going to come back to it. Now, 12 can be broken down again into the square root of 4 and the square root of 3. Now, the square root of 3, that's a prime number. We can't go anywhere with that. I'm going to circle it, hold on to it. We're going to come back to it. But this, the square root of 4, is 2. That is a perfect root, so I'm going to circle that. Now, what do you notice here? Everything we're left with has been circled, okay? Now, we cannot multiply a regular whole number directly to a radical. It's not going to work out nicely for us because we also aren't using calculators. But what you can do is take a radical 3 and a radical 2 and combine them together, and they will create a radical 6. 2 times 3 giving you 6, and they're both under a radical, so you can combine them together. Now, don't forget that you still have this 2 right here, so you are actually going to get a final answer of 2 square root 6. Okay? All right. Now, if you had chosen a little bit simpler numbers here, you could have broken down 24, just to show you it could work out faster, into the square root of 4 and the square root of 6, and it would be even faster. So I just wanted to show you a longer method because some students will immediately think, oh, I have to use 2 and then use some other number. But I'm telling you, if you can find the matches that are closer together, there usually is a slightly faster way to get to that final answer. All right, so let's take a look at the second example problem here. Now, this is a good one to show it by breaking it up into its parts. So let's do that. Okay, this is the same thing as saying the square root of 25 times the square root of x times the square root of x. All right, what I'm doing is this says it's squared, so I wrote it twice. Okay, to break it down into all of its parts. Again, it's squared, meaning I have 2 of these guys. Okay? Now, the square root of 25, that is 5. So that one works out perfectly. Now, here is a nice little trick. If you have the same thing under a square root and they are being multiplied together, it actually works out to just be what is underneath that square root. So what I'm saying is the square root of x times the square root of x. Notice they both are x. The answer of that is just x. So that would mean that our final answer here is just 5x. Okay, this is a really important thing to remember. Okay, so make sure you heard that. It's important to remember. If you have the same thing underneath the square root and you're multiplying them together, your answer for that that's coming out will just be what is under the square root. Okay, so hear me on this. If you had the square root of 3 times the square root of 3, what would your answer be? It would just be 3. Okay, now if you need a little bit more math to that, the square root of 3 times the square root of 3, you could say, okay, well, that's the square root of 9. Well, what is the square root of 9? That's 3. Okay, so that's a helpful tool. Remember that. All right. Now, let's take a look right here. Example problem number 3. Again, let's break it all up into its pieces, and let's see what we get. Okay. We have a square root of 2 times a square root of 3 times a square root of 3. Oh, sorry, square root of 3, we're going to have 3 of those. Okay, so what I mean by that is x to the 3rd power is going to give us these 3 x's right here. Again, x to the 3rd power, there's 3 x's. That's why we have 3 x's right here. Then we have this one more x that is being brought down right there. Okay, so I want you to notice now it's like we have 4 x's. Okay? Now, remember what we just did in the second example problem. If we group these guys up, in other words, I have these guys right here together, what is the square root of x times the square root of x? That's just x. You got another one. What's the square root of x times the square root of x? That's another one. Multiplying them together and then multiplying that by the square root of 2. The square root of 2 can't go anywhere. 2 is prime. That one's done. But you should notice that you have an x and another x, giving you a final piece of square root. I think we can do a better job there. Square root 2, and then in front of it, x squared. Now, I want to make sure you notice that I'm putting the radical or the square root last. It's the final piece of the expression. If something is not under a square root, you put it first. You put it in front. Okay, so that's why you'll notice I have the x squared that came from this right here, x times x, giving us x squared. That's in front. Then I have the square root, which came from here. That is at the end. Square root goes at the end. Not under the square root goes at the beginning. Okay, let's move over. 4th example problem. Let's rewrite this. Okay, we have a division problem, but let's break it down into its parts. Square root of 1 divided by the square root of y times the square root of y. There's a 2. There's 2 of these guys right here. Okay, remember, they're both the same. They're being multiplied. They're under the square root. So what's the square root of y times the square root of y? It's just y. And the square root of 1 is just 1. That one works out quite nice, right? What's 1 times 1? 1. All of that, there's your final answer for that one. All right. Okay, and we do have a couple more. Sorry, guys, but this is an important concept. Let's keep working, keep working, keep working. Okay, so 3 on top, no square root. That's great. Leave it, don't mess with it. Unfortunately, though, the square root of 2x on the bottom, that can't be simplified to anything, right? The square root of 2, that can't go anywhere. The square root of x, that can't go anywhere. So this is going to be one of those problems where we go back and say, okay, you cannot leave the square root in the denominator. So this is where you have to multiply the top and the bottom by whatever that denominator was. Our denominator was the square root of 2x. How do I get rid of that? You multiply it by itself. That's the thing that I've been teaching you this whole time. Square root of y times square root of y, well, that's y. Notice the radical disappeared. That means if I have the square root of 2x and I multiply it by the square root of 2x, it's the same thing under the radical. What is that going to become? That means my denominator is just going to become 2x. It's the same thing under the radical, so that radical disappears. Now, what are you left with on top, though? 3 square root 2x. That can't go anywhere. 3's prime, we're done, can't go anywhere. Square root of 2 can't go anywhere. Square root of x, that can't go anywhere. This problem is now done. We couldn't go any further, but the key piece that you should have noticed is we needed to get rid of that square root in the denominator, and we now did. All right, last example problem. Here we go. Okay. This piece right here, 2 square root 7, I can't do anything with that. 2, nope, can't magically change that. Square root of 7, 7's prime, can't do anything there. But the square root of 63, I can break that down. We need to make a factor tree. Break this down into the square root of 9 and the square root of 7. 9 times 7 is 63. Square root of 9 works out perfect. Square root of 9 is 3. Square root of 7, we can't go anywhere with that. Now what you have to see is, what did we just create here? Let's zoom out a little bit, get a little more space. We have a 2 square root of 7. All right, that's just this guy, bringing it down. But what do we have left on the other side? Plus 3. That's this 3, that's that 3. But now times 3 times square root of 7. This 3 is this 3. This 3 is this 3. And then square root 7, right there, square root 7. So you should now see I actually have a 3 times a 3. That will give me a 9 square root 7. And on this side, we still have a 2 square root 7. Now, notice how both sides have a square root 7. That's the same exact concept as saying like terms. If you had 2x plus 9x, what would that give you? That would give you 11x. The exact same concept applies here. They're both square root 7s. So 2 square root 7 plus 9 square root 7, like terms, will give us 11 square root 7. Because they both had a square root 7, I'm allowed to combine it one more time. Whew, okay, there we go. Let's zoom out. There's that page with example problems. and the first page with example problems. That's what I got for you guys. I know, slightly longer video. Stay strong. Keep working hard. Take all these notes. Ask questions if you have them. I'll see you in the next video.